for tonight. And this is a model. It's kind of an exciting model. This is a model of Da Vinci's ornithopter. You can see here the wings and all the different aspects of that flying machine that Leonardo da Vinci thought up many years ago. This is also set up with kinematic mechanisms. I'm going to grab onto that crank and turn the crank, and you can see now that the wings are flapping and the gears are turning. The man is pushing the pole back and forth, and all the different aspects of the kinematic linkages are working. And this is really helpful when you're trying to design these mechanisms to be able to try out all of your gears and your sliders and pin joints and so forth to make sure that they all work. Now, one of the other nice things about building a model in PTC Creo is that you can do all kinds of analyses with it. So I'm going to jump up here at the top and click on my Analysis tab. And here you can see now I have a whole host of tools that allow me to do different kinds of analyses. And probably the simplest is to do measurements. So I click on the ruler. It gives me a bunch of different options. You'll see I can measure length. If I click on the length and then I click an edge, it'll tell me what the curve length is. I can click on the next tool, which is to measure distance. And so in this case, I'm going to click on one point. I'm going to press Control and click on another point, and it'll tell me the distance between those two corner points. I can measure angles. So I click on the Angle tool, and now let's see. Let's take a look at, I'm going to click on this edge and the other edge of the leg, and that will tell me the angle between those two legs. I can measure diameter. So I click on the diameter tool, I click on the edge of this gear, and that will tell me the diameter and radius. I can measure surface area. So I click on the area tool, and I'm just going to click on the top surface of that yoke, and you'll see it'll give me the total surface area of that yoke. And finally, I can calculate the volume. So maybe I want to calculate the volume of the entire model all put together. I click on the volume tool. I come over this time. Instead of trying to control click all of the different parts and pieces of my model as I see it in the graphic window, I'm going to come over to the model tree and just click on the top level assembly, and then you'll see right down here that the total volume is 45.1088 inches cubed. So those are some pretty powerful analysis tools that allow me to do measurements on my model. And you can see the value of this once you have the model of your robot. Then you can use these tools to measure distances, to calculate surface area or angles or whatever. It's also helpful when you're in the process of designing your robot to be able to use those tools to measure lengths and angles and so forth. Another very helpful tool is the Mass Properties tool. So I'm going to click on the Mass Properties tool, and you'll see a dialog come up. And this dialog box allows me to calculate the mass properties of my model. I'm going to come down here to the bottom. There's a set of eyeglasses. That allows me to just preview the calculations. And here you can see it's calculated the total volume, the surface area, average density, the mass, and the center of gravity. And if I rotate this around a little bit, you'll notice that the center of gravity is the coordinate system with the 1, 2, 3 that's just below the knee of the wooden man there. That's the center of gravity of that model. That's really an exciting thing to be able to calculate the center of gravity, particularly of your robot, because the center of gravity dictates in so many ways the performance of your robot. Now, since I have kinematic mechanisms and relationships and so forth built into this model, I can move into a different room now in my virtual design studio. I'm going to click on Applications and go into the Mechanism room. And in the Mechanism room, now I can start doing simulations of all the different mechanical parts. You'll notice that the model tree has now split into two parts. I have a model tree and I have a mechanism tree. My mechanism tree gives me all the different kinematic connections and mechanism relationships that are a part of my model. And it turns out that I've set up an analysis here called wing flapping. I'm going to right click on it and I'm going to say run. And all this does is it turns on a virtual motor that I set up here that turns the gears. So PTC Creo goes through a full cycle and calculates all the positions and velocities and so forth, and then stores that as a playback. So then I can right click on the playback. I can then run this. I'll change the speed so it goes a little bit faster, and while it's playing I can actually move around, zoom way in, see the parts actually moving. You'll notice here I've got some interference. This allows me to check and see if I'm going to have interference in my motion. I can even capture this if I click on the capture button and capture it as a video file. So this allows you to set up your robot with all of its kinematic joints and its mechanisms, its gears and belts and so forth, put in the motors and turn those motors on, have your robot wheels going, have your arms moving and so forth. And you can capture that as a video, and then you can bring that in to do your design reviews, to talk about where you're having problems, where you need to make changes, and you can even use it to show your judge as they come into the pit and want to talk to you about your design. You'll have that video to be able to talk about when you have the motion, why you designed it the way you did, and so forth. So I know